It was such a wild night. It was thundering and lightning all night, and especially at about 3 or 4 o'clock in the morning, it just really started rumbling. And man, did we have the thunder! It was so crazy. And my dog, he does not like the thunder at all, so he was shaking in his fur. I was going to say his boots, but he didn't have boots. So he was shaking in his boots. So in his fur and his little claws. But anyway, we have a lot of fun lined out for today as far as Math Flip Flat Frenzy goes. So I'm playing some basic versions of the game and also some advanced versions of the game. If you can see me live, I would love if you could join me and show the chat with me. Let's see. I guess I have to connect to chat. Okay, we'll see if you can join me in the chat, and we'll do some math coming up here. Okay, I'm going to give people a couple of minutes to get signed in. Gotta change things out here. I was doing some other videos today, so gotta get this switched around. Here we go. Thanks for being here with me today. I've been trying to get this. If anybody on here knows how to get Streamlabs connected to all the platforms without giving you problems, I would love to have your tips and advice. I've been using, trying to get some help on that because I'm just kind of stuck in being able to only connect to YouTube right now. Should be able to do all the platforms. Okay, let's get to business here, which is Math Flip Flat Frenzy, the reason we meet every morning. Just to let you know, I'm also going to be going live for a 10X Health product that I'm going to be rolling out and doing some coaching to help you become the healthiest you can be, taking control of your health based on your genetics, and then also working with people to become better at business and really a mindset shift on where you can be in your life. But today we are really focused on these children and getting math fluency to be prominent because we know that it is a big problem in America. So here we go. We are working on the 221 basic version of the game, and I'll tell you what that means because it is based on, let me get that down. Gotta maybe find some better equipment one of these days. We'll see. Get that up. Okay. And working on 221. That means that we are rolling 2 pair of dice. So a pair of dice and a pair of dice. And then the result of that equals the equation to flip something down. Okay. Right now we are on the 3rd roll. And I'm going to show you the magic of this game. I've actually, over time, since I've been playing this, going live with everyone, I would say that this one is probably my favorite game as far as the creativity and the thinking skills, using variables and how this can apply in stats and kind of like future kind of things, the math skills that are being developed just in this 221 version of the game. And they're just 1st and 2nd graders, 3rd graders. And so the thinking that really happens in here is going to be mind-blowing to you. So let's look at roll number 4 for today. And I'll explain as we go how this works. We have a 3 and a 1 and a 3 and a 3. So these pair of dice are going to create an equation. So I have the 3 and the 1 for the purple and the 3 and the 3 for the blue. So 2 different colors. And then the result of that, we have to create an equation from that. So this is roll number 4. And the back of the score sheets in the book are blank so that students can show their work, or just at home if you're playing this as a family. I don't have to call you students all the time. So we have a 3 and a 1 and a 3 and a 3. Now, the numbers have to be completed as pairs. So we can only add or subtract, so 3 plus 1 or 3 minus 1. So the result of that would be 3 plus 1 is 4 and 3 minus 1 is 2. The other side, we have 3 plus 3 is 6, or 3 minus 3 equals 0. Now we're going to look at this and see what kind of equations, because now we have to have the result of one color plus or minus the other color. So we can start with this and go this way, or we can go this way. So we'll start on this side where we have the 3 plus 1. So we'll start with all the 3 plus 1s plus 3 minus 3 equals 0. That one equals 0. Now we have 3 plus 1 plus 0 equals 4. Sorry, I just said the wrong thing. So you have to do them as pairs. Nothing like saying the answers out loud. When I was a teacher, I would do the same thing. Okay, now we're going to do 3 plus 1 plus now that has to be done together, plus 3. Instead of subtracting it, we'll add it. Equals 4 plus 6 equals 10. Now, we've done both of the 3 plus 1s on this side. Now we can do the 3 minus 1. Well, we can't do 3 minus 1 and subtract the 6, but we can add it. 3 minus 1 plus 3 plus 3. So now we have 2 plus 6 equals 8. Now, what if we wanted to do 3 minus 1 minus this? So now we can go 3 minus 1 minus 3 minus 3. So now we have 2 minus 0 equals 2. Now, what if we want to do the other side first? We could put the 6 up here first. We could do the 3 plus 3 on this side. Now, teachers, if you're teaching the commutative property, you could teach them the commutative property with pairs. So 3 plus 3 plus, we have the same equation up here, 3 plus 1 equals 6 plus 4 equals 10. So this is the commutative property because they're the exact opposite. It doesn't matter where you start. You could do commutative property with addition. So just like going, I used to use this as an example when I was teaching in Canarado, Kansas. I was like, well, I'm going to commute to work in Goodland. And then when I go home, I'm going to do the opposite. So I'm still getting to the same destination. I'm still going to have the same answer, but I'm just doing it the opposite direction. So 3 plus 1, Canarado to Goodland, Goodland to Canarado. So commutative property, just commuting and going different directions. Okay, that's just a little side note. Okay, here we go. So we get to choose an answer from here. And player number 1 has the opportunity to put down, the 8's already down, but we have a 2 or a 10. So I think this player is going to go ahead and choose the 10 since we commuted across the lines there. We'll go ahead and use that one. So 3 plus 3, here we go, plus 3 plus 1 equals 10. So Canarado to Goodland, Goodland to Canarado. So 10. All right, here we go. So we're going to put down the 10. Okay, next player. I just wanted to teach you a little bit about that commutative property if you're having a hard time figuring out a way to teach that. Okay, if you want ideas on how to teach the associative property, I love that one too. But we'll do that when we get into the other games. Okay, next player has a... and the properties are just to help kids understand how numbers work together. All right, here we go. 3 and a 6 and a 3 and a 2. So, color 1, 6 and a 3. Color 2, a 3 and a 2. Now we're going to do the same thing, figure out what numbers are going to work to flip down a flap for player number 2. But I'm not going to do that just yet. We're going to go to the next player so that if you're online and you want to be player number 3, you have your chance to put it in the comments and show me how you are using the pairs to make or flip down a flap on the box. Now, 4 and a 3 and a 3 and a 1 for player number 3, 4, 3 and a 3, 1. So don't forget, these have to be pairs. That's why there's 2 different colors. And really working on, you think about it, this could be stats, it could be used in chemistry, it could be used in biology, just like, what if I did this and subtracted that? What if I changed this variable? What if I added one extra thing to that? What if I subtracted one thing? This is a lot of the what ifs that come in math, and then really creating stats and writing coding and things like that. So a lot of fun, a lot of things that can happen just by understanding working with pairs of numbers. Okay, player 4, here's your roll for today. You have a 6 and a 3 and a 6 and a 4. 6, 3 and a 6, 4. Now, you have a 7, 8, and 9 down, so let's try to make those numbers equal something to flip down one of your flaps. So we have a 10 minus 9. We could do 6 minus 3 is 3, so we could go 10 minus 3 would be a 7. That's already down. You could do 2 plus 9 is too many. So you could go 6 and 4. 6 minus 4 is 2. 2 minus or plus 3 would be 5. Oh, there you go. So you could do your 2 plus 3 is 5. So as you're working those numbers on the back of the paper, you can see that you'll be able to flip down a 5 today. So just show me your work. And that's a great way that you can track all the work with your... If you're using it in class, and it's just a great thing, we're going to work on pairs, we're going to work on commutative property, we're going to work on this, and guess what? You get to use this really fun game to show the commutative property. They get to choose different ways to do it, and they're the ones creating the equations and coming up with their answers. All right, that is for the basic version 221, playing that today. A lot of fun. Now, moving on to the more advanced version of play, just to level up. Now the students are able to use multiplication, division, addition, and subtraction. And with the addition of rolling doubles. Now, as your students get older, they can handle more fun. And so they will be able to play the game and use the mystery cards. Now, mystery cards can create some havoc and some frenzy, or it can create some great things because now they might be able to flip down more flaps. So yesterday, player number 2, who is 1 now, had A plus B equals 8. Put down 2 numbers that equal 8. If the 8 is down, put it up. So 2 numbers came down, 1 went up. So an extra number down yesterday for this player. And this player has already had to trade places with somebody just due to drawing the mystery cards. So you don't want to use mystery cards. You can sort them, I suppose, if you wanted some mystery cards with the younger students. But really, you want to focus on the math fluency in the younger grades, and then in the advanced versions, you can add in the extra fun. All right, so we are rolling now 2 12-sided dice for a little more extra fun. Now, when you start the game, you want to just start with the 10-sided dice. But as your students are, advancing in their math skill level, you can add the 2 12-sided dice. We tried it in the classroom with all 4 12-sided dice, but that creates a few problems and you got to think about timeliness as well. So let's roll the dice for today. 2 12s and 2 10-sided dice. And look at this. It's crazy. There's only been one play that this player has not rolled a double. So today, 2 5s, a 3, and a 1. What kind of mystery card are we going to get today? Got the numbers written down. Okay, over to the mystery card pile. Now, sometimes there's rock, paper, scissors. Sometimes there's trade places. Sometimes there's just do something silly. So we'll see what kind of mystery card is going to show up today. Okay, A plus B equals 7. Put down 2 flaps that equal 7, and if the 7 is already down, flip it up. I'm trying to make it in focus. It's a little blurry. Oh, there we go. Well, there are 2 numbers left for me to flip down that equal 7. Now, this is great for students to think, what numbers equal 7? I could do 6 and a 1, a 5 and a 2, a 3 and a 4. Okay, but all of those are already down. And if the 7 is down, flip it up. I'll tell you what, this player has had a heck of a time with that number 7. So the 7 goes up. When the card is done, it goes to the bottom of the deck. So you always have to do the mystery card first, and here's why. So the 7 went down yesterday. Mystery card, A plus B equals 7, and then 7 up. Now look, the 7 was down, the 7 went up, the 7 went down, the 7 goes up. So again, that darn 7 just does not want to stay down. Now, it's important that before the next player completes their turn, this player has to complete their turn, because if a mystery card is drawn, there might be a consequence that happens, and they might have to flip a number up or down. So you want to make sure this player completes their turn by adding, subtracting, multiplying, dividing with the numbers. Okay, so let's do a little bit of math before we go to the next roll. I won't do the math for everybody because I want to make sure you're trying it yourself. So we have 2 5s, a 3, and a 2. Whenever the kids are doing their work, make sure they circle what problem number it is so that everything stays nice and clean. Well, this one is going to be kind of simple, except that I have a 5 down for this player. So 5 times 5 divided by 3 plus 2 equals 5. So 25 divided by 5 is 5, but I can't use that one because I already have that number down. What if I did 5 times 3 minus 5 times 2? Well, we're going to get the same thing. So we have 15 minus 10. That's also 5. Well, that's not going to work. How about we do I'm trying. This player needs all of the high numbers. So we're going to have to figure out something that can get a high number down. What if we did, how about this? 5 plus 3 is 8. Plus 3, there we have 8, 9, 10, 11, minus 2. Okay, now we have 8 plus 3 is 11, minus 2 is 9. So this player can get down the 9. Now, no multiplication or division was done there. Oh, that's not right. What did I do wrong here? This has to be a 5. 5 plus 5 is 10. Plus 2, let's do it that way. It's still going to be the same thing. Look at that. 10 plus 2 is 12. Minus 2, is... Nope, that has to be a 3. Still 9. Okay, wow. Let's just rewrite that. It was kind of messy. 5 plus 5 plus 2 minus 3 equals 10 plus 2 is 12 minus 3 is 9. I just had written the wrong number there, so I had to make sure you have to use all of the numbers in the equation. So the player can flip down a 9. What if I wanted to use the 10, 5 plus 5 minus 3 times 2? Now tell me in the comments, do we need to put parentheses around this? Okay, what do you think? Do we need parentheses around anything in this equation? Now, following the order of operations, what do we have to do first? All the multiplying. So we multiply first. 3 times 2, that's 6. Rewrite the equation as I teach the students. Now we have all the addition and subtraction is left. So 5 plus 5 is 10. 10 minus 6 equals 4. Now that will flip down a 4, but this player already has the 4 down. Right now, the only viable option is, what if we did 5 times 3? What if we did that? 5 times 3, that's 15, minus 5 plus 2. Now, 15 minus 5 is 10. Plus 2 is 12. Well, we can't do it that way. What would we have to do to make this equal to 7? If we did this, look what the answer would be. I'm just going to show you the difference. 15 minus 7, or 15 minus 5 is 10 plus 2. That equals 12. What if we did 5 times 3 minus 5 minus 2? Now we have 15 minus 5 is 10 minus 2 equals 8. Now what would happen if we did 5 times 3 minus parentheses 5 plus 2? Now we have 15 minus 7 is 8. But we put the parentheses around it, so it changes the outcome from when it was there. Now if we did 5 times 3 minus 5 minus 2, well, that's not going to work, right? Because now we have 15 minus 3 is 12. So we're back to that. So by putting parentheses, you get the same outcome, but not with the same equation. So this one was when we added the 2. This one is when we subtracted the 2. So you can just see that how those parentheses can change everything. So this player is going to go ahead and flip down the 8. Okay, we'll move that to the front. Uh-oh. Look at that. I did all the work. 5, 5, 3, 2. None of the work is legit because it all has to be a 2. The 2 has to be a 1. I copied the numbers wrong. So now we have to do this again. What if I did, let's see, this was going to be an 8. So we're going to subtract a 1 instead. So this will equal a 9. Just in lieu of time, I'm just going to go ahead and use that equation and change that to a 1 instead of the 2 because I copied the numbers down wrong. So 5 plus 5. What did I do? Did I do 5? 5 times 3 times 3 minus 5 minus 1. No parentheses because it'll change the answer. So that's 15 minus 5 is 10 minus 1 is 9. So the 9 is going to go down. Okay. So, and that's how you check your work. It's like, oh, bummer. I did all that work with the wrong number. So I had to change that to be a 5, 5, 3, 1. So all of those would have to be adjusted. Wherever the 2 is, adjust it with the 1. I didn't do any multiplying by 2, so yeah, I did right here. That'd be, that would equal 10. So 5 times 3 minus 5 times 1 So that would equal 10. Okay. All right. Now, we're just going to move on to the next player. And make sure you're copying the right problems onto the back. Here we go. Okay. The right dice roll onto the back to do your work. Player number 2. Here we go. You have a 12, 10, 8, and 7. 12, 10, 8, and 7. No doubles for you, so we can go ahead and move on to player number 3 because there is no consequence card to be worried about. Okay, and here we go. This player, 9, 7, 6, 2. 9, 7, 6, and 2. No mystery card to be drawn there because there are no doubles. And then on to player number 4. Here we go. It is a 0, which can be a 10. 8, 4, 3, and a 0. 8, 4, 3, and a 0. Okay, there we go. 8, 4, 3, 0, and it can be, the 0 can be a 10 or 10. So we'll get to do that. Now, no doubles there, so nothing to draw from the mystery card pile. Okay, that is how we play the game. Just making sure that you're multiplying, dividing. Students should make sure they write there, or even at home, write this down. When Steve and I are playing, it's like, what can I do in this game? I can add, subtract, multiply, and divide. That is what we can do. Okay, that is